Hello, this is part one of chapter 8, lesson 3. So, what we're going to take a look at with this lesson is some special right triangles. And so, today we're going to take a look at our first one. Our first one comes from this shape. So, here's a little note page that kind of guides you through the process of filling out this information of thinking through aspects of these triangles. So my first question is, what kind of shape is this big shape here? Well, hopefully you're saying it's a square. And let's try to label the parts of the triangle. So if I think basically I want you to label these question marks. So how many degrees do you think these angles would be? If this whole thing is 90 degrees, what would half of 90 degrees be? So half of 90 degrees is 45 degrees. And this would also be 45 degrees. So this is called a 45, 45, 90 triangle because the angles are 45, 45, and 90. Make this a little bit bigger. Because the angles are 45 degrees, 45 degrees, and 90 degrees. And so a 45, 45, 90 triangle comes from a square, and we can break apart those parts knowing the aspects of a square. So this would be the hypotenuse. This would be the hypotenuse, and these would be the legs. So let's label them L for legs of a triangle, okay? Let's use the Pythagorean theorem to solve for the hypotenuse. So basically, I want you to use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. And so we are going to solve for h and get h by itself. So if we do this, we have L squared plus L squared, which really we could say is 2L squared, right? 2L squared equals h squared. And then we know to get rid of our square root, we would square root both sides. But what we have here, if we square root both sides, is we have square root of 2 times L equals, and this is gone, so this equals h. So let me rewrite this a little bit. H, the hypotenuse, equals the legs times square root of 2. So this is just the background of the big part of what we're going to do here. So the 45, 45, 90 triangle theorem says that anytime I'm looking for the hypotenuse, my legs are just going to be square root of 2 times the legs equals the hypotenuse. So we can write that again right here. Hypotenuse equals legs times square root of 2. So let's do a few practices on our study guide. Is that it? Where is it? Right here. So on our study guide, we're going to just find x. So that's the hypotenuse here. So if my leg is 8, then our x would be 8 times square root of 2. Let's do number 3. If this leg were 4, then the hypotenuse would be 4 times square root of 2. Okay. Let's see. I think all the other ones, the hypotenuse is given to us. So working backwards, let's look at number 2. If the hypotenuse was 3 times square root of 2, then we know that x would be 3, right? X equals 3. So we know that the pattern is, if you even want to draw this down, x, x, x times square root of 2. And we can call this a radical of 2. So kind of rhyming, a little saying that kind of rolls off your tongue would be x, x, x rad 2. And so that would be a 45, 45, 90. Okay. So those are the qualities of the sides of a 45, 45, 90 triangle. So looking at number 6, x, x, x rad 2. So that means whatever this rad 2 is would be x. So x equals 24 here. That's 24. Okay, I'm caught in a dilemma. I've got a hypotenuse that doesn't have a radical. 18 and 16, those don't have a radical. So let's go back to our notes and let's add on a few things. So if we are given a triangle where we have the hypotenuse and it's like a whole number and we need to find the legs, well, let's use our template equation. Basically, we know that 12 equals x times radical 2, right? Or, yeah, 12 equals x times radical of 2. So we can work backwards. We can work backwards to solve. So if I'm multiplying by radical of 2, I'm going to divide by radical of 2. Now here's the problem. With fractions, we do not want to have a radical of 2. So here is what we're going to do. What we're going to do is we're going to multiply by radical of 2 over radical of 2. And that is going to end up being where when I multiply my denominators and when I multiply radical of 2 over radical of 2 here, that's just x, right? These cancel out, like these cancel out, and then I'm left with x. So that will help me find x. So when I multiply my denominators, radical of 2 times radical 2 equals, remember we talked about this last class, any radical times itself equals that number inside the square root. So that's 2 on the denominator. And then I have 12 times square root of 2 equals x. And if I want to simplify this, I can simplify this where 12 divided by 2 is 6. This is 1. And so I have 6 times radical of 2 equals x. Okay, what do you notice about 6 and 12, those two numbers? 6 is just half of 12, right? So x is 6 times square root of 2. So we realize if we do this a few times, we could try it on this one here, is I think I'm going to get half of what the hypotenuse is times the radical of 2 as my leg. So that's another thing that's interesting. Let me work this problem out. I'm going to erase this stuff so that I have room. See if I can get rid of that stuff so that I can have room to do this bottom one, and then we'll see if we can fill out this pattern. Okay, so again, we have the hypotenuse equals the legs times radical of 2. So 10 equals y times radical of 2. So I'm going to divide by radical of 2 here, divide by radical of 2 here. And the reason why I'm going to multiply by square root of 2 over square root of 2 is because basically anything over itself is 1. So I'm really not changing, I'm not multiplying by a random new number. I'm just multiplying it by 1, right? Anything times 1 is just itself. So I'm not changing the problem. I'm just rearranging it so that it's easier for me to work with. Okay, these cancel. And square root of 2 times square root of 2 is 2 on the bottom. And then 10 times square root of 2 is left on top, and that equals y. Again, I can cancel out 2 and 10, and this on top would be 5. So I have 5 times square root of 2 equals y. Notice how y is just half of the hypotenuse times square root of 2. So this is a pattern that we see when the hypotenuse is given to us. So what do you think z would be here? I think it would be 8 times square root of 2 and 8 times square root of 2. B would be 10 times square root of 2 and 10 times square root of 2. So if you know this pattern, you really don't have to work it out a bunch, but it takes a little bit of memory, right? You've got to remember it a little bit. So let's go back to our study guide. On our study guide, we have number 4. This is 18. So x would be half of that times square root of 2, 9 times square root of 2, right? Number 15, we actually did this one already, but half of 16 would be 8, so it'd be 8 times square root of 2. And so we really don't need to go through and work out all these problems if we remember the pattern. So the pattern in the theorem actually saves us from having to work out a bunch of geometry or algebra. Let's take a look at these 3 problems here. Word problems describing a picture. So I would suggest drawing a picture would help us identify the parts the best. So if a 45, 45, 90 triangle has a hypotenuse length of 12, find the length of the leg. So we know the pattern that it's x times square root of 2, or x rad 2. But because I'm only given my my hypotenuse, it would be, to find the leg, would be half of the hypotenuse times square root of 2. So the answer, the leg, would be 6 times square root of 2. Okay, so if these were my x's, that would be what that is. Number 8, determine the length of the leg of a 45, 45, 90 with a hypotenuse length of 25 inches. So this time you have, let's say this is y and y, and this is 25. So we have to just divide 25 by 2. 25 divided by 2 is 12.5. So it's 12.5 times square root of 2. And then number 9, it says you've got a leg where the legs are 14 centimeters. Find the hypotenuse. Well, the hypotenuse would just be x rad 2. So whatever the leg is times square root of 2. 14 times square root of 2. And with these lessons, because we're learning the pattern, and that's more the focus than actually the answer, so you don't have to write your answer as a decimal. You can just leave the radical there. All right. I'd like you guys to pause and try 1 through 8 out. I will put the answers up here, but try 1 through 8 as a little bit of a practice, and then we'll be done for today. Okay, let's check your answers. Here you go. So these are the answers. Number 1, 25 times square root of 2. Number 2, 5.8 times square root of 2. Number 3, 48 times square root of 2. Number 4, 50 times square root of 2. Number 5, 100 times square root of 2. Number 6, 44 times square root of 2. Number 7, 13 times square root of 2. And number 8, 50 times square root of 2. Okay, our next lesson, our next video, will be going over another type of special right triangle. So we're only doing half of this lesson in this video, and I'm breaking this up to 2 parts so that there's just you're not overwhelmed with new information. But that's all I have.